Welcome to the UGC e-Pathshala lecture series in computer science. In this series of lectures, we have been looking at software engineering subject, and for today's module, I'll be giving a hint on developing software lifecycle. Major learning objectives for today's session would be is to ensure the delivery of high quality systems. We'll be providing strong management controls and how does this optimize or maximize the productivity. Some of the technical activities pertaining to this software development lifecycle includes system definition, which includes analysis, design and coding. Most of the software development lifecycle involves a cyclic process of analysis, design, coding and testing. As I've already mentioned, ADCT would be the basic principle underlying software engineering practices. So, we will be looking at major of analysis, coding and design into system definition aspects, and we will be taking up the output of this particular module into testing, system installation, production support, defining releases, evaluating alternatives, reconciling information across phases and to a global view, defining project's technical strategy. The management activities of software development lifecycle. Every project has to set up with own priorities. So, setting up a priorities becomes a key aspect of software development lifecycle, by where we will be defining the objectives, we will be keeping track of the project and the status reporting every now and then, whereby we maintain the time schedule. Change control, risk assessment, stepwise commitment. So, all this at later point in time will be dealt in terms of modules. The other aspect of the management would concentrate mostly on cost benefit analysis, user interaction, managing the vendors, post implementation reviews and quality assurance. Basically, when we look at any software that is being developed, we will be talking about the software in three different perspectives. The outcomes of the software will be looked at from three different perspectives. One is the time, the second would be on the quality and the third one would be on the cost incurred. Looking at the same software development life cycle, a standardized format of the software development life cycle would be something like this, where we start with the planning, where we actually formalize on how much span required to complete every module of a project, that means every unit wise procedure of the project, organizing it and running a new development project. So, these three issues will be of major concern and we will be revolving around them consistently. Planning with the models. Software engineering projects usually live with a fixed financial budget. This even does not cover maintenance. There will be a fixed budget which will be assigned at the beginning of every phase. So, before we try to understand the requirements and we plot the know your customers, we will be actually working on the total budget to be incurred for this particular project. This does not involve the maintenance strategy. Additionally, this also requires a time to market, places a strong time constraint when it is to be marketed. Say for a traditional approach of software engineering, although we come up with different life cycle models, any traditional approach of software development life cycle has to go through a requirements phase, analysis phase, design phase, implementation phase, testing phase, operation phase, installation phase. These different phases has to go across over a time period. So, there are limitations towards time constraints also, which will also be addressed when we plot it as a architecture. So, there will be other project constraints such as staff also. So, manpower involved and the effort which will be estimated will also be a constraint when we work on the models of software. So, typically looking at the different constraints of a project in turn involves four major modules. One would be the staff, the other would be the cost or the money, the third one would be the computing resources and the fourth one would be the time. If you look at the staff, there are different hierarchy of staff who will be involved for the software. One would be the programmer, the other one would be the designers, the other people would be the managers who are typically involved for a custom built software or any type of generic softwares. And if there are any scarce or shortage of resources from the staff perspective, this should be addressed. The risk of the project would be more. Likewise, money, computing resources and the time, or computing resources, or otherwise it can be mentioned as the infrastructure facilities. This also would lead to a major constraint towards a project. So how about going for a planning of a project? A project planning is the art of scheduling the necessary activities in terms of time, space and across staff in order to optimize. So we may have to majorly optimize on certain things. One is we have to understand the risk component associated with every project. The risk should be low as possible. The profit towards the project need to be as high. The customer satisfaction should also be high. The work satisfaction should also be high. That is, the team members who are actively involved in the project should be satisfactory enough to develop a quality software. And this phase of development would fit into a long-term company goals. Going in further on the project planning, a project plan contains much more information but must at least describe the resources required. The major resources that a software project would require are the people, money, equipments. The other factor that is of a major concentration towards project planning would be dependency. How dependent is one module or how interconnected is one module with the other component of the module. So, and the timing of the work. Say for figuring out these issues, we will be drawing flow graphs, work packages and different use case diagrams will also be drawn. The third constraint working towards this project planning would be on the rate of delivery. We will not be actually plotting out the overall schedule of the project at the beginning. We will not, although we are not able to correctly plot on the time frame, but the rate of delivery also plays a vital role. So we look at the reports, code, documentation, etc. Although it is worth spending time towards planning for a particular project, but it is impossible to measure the rate of progress except with reference to a plan. Unless or until we are not very clear with the planning aspects, we will not be able to correctly figure out what we wanted to work on. The next focus towards the plan would be on the visibility of the project. How many of my customers would be looking at the project in future. So unlike the other engineers like civil engineer, electronic engineer, chemical engineers, mechanical engineers, the software engineers do not produce anything in physical. That means it will not be that easily measurable as it was with the other sort of core engineering disciplines. Hence it is inherently difficult to monitor the software engineering project due to the lack of visibility. This means that the software engineering must produce additional deliverables or the artifacts like design documents. At every phase of the development of software products, we may have to produce certain level of documents. So as I am doing with the requirements, I will be working on the requirements document. Likewise, working towards the design, I will be producing a design document, or I will be building a simple prototype which basically gives me an understanding of how this software would be. Flowing through that, I will be preparing a report. Then I have to make a continuous progress, or I have to track on the changes that I have made towards the project, which requires constant status meetings. And finally, it goes towards a client survey where the satisfaction level of all my customers who are about to use my product will be tested. Working towards the same progress project planning. Once after I have done all these stages, that means I have gone through a phase of resources, dependency, timing and rate of delivery. Now by visualizing on the plan visibility, the project's visibility, I will be able to certain point of time figure out what is exactly required and what will be the deliverables over a time span. Coming to a specific plan, I will be able to majorly figure out the software lifecycle model, First, we'll try to define what exactly is the lifecycle model. A software lifecycle or a system lifecycle model generally describes or is a description of a sequence of activities. As I have already mentioned, analysis, design, implementation, testing. Likewise, there will be a sequence of events which will define clearly on the lifecycle phases. So, is a description. Lifecycle model is just a description of sequence of activities carried out in a software engineering project and retrieve order of these activities. So, it is not the point that I do whatever task that comes to my mind. Instead, I execute all this as a sequence of events. Further, it provides a fixed generic framework. So, every model has got its original framework that can be tailored to a specific project. So, it is my responsibility to adopt to any specific framework with which I will come down every stage or I progress through a sequence of phases by where I will be very clear, say after I have collected on the requirements. If I am clear on my requirements after doing all my analysis, I will be able to clearly sketch on the design of the project. So, this is how the sequence of activities would help to coin a model, and this model now we are terming it as software development lifecycle model. And this will be a project specific parameters which includes size, budget, duration. So, the major concern towards software lifecycle model would be on the amount of effort that I am putting towards development of the software, which is calculated in terms of person years, the overall estimate in terms of money which will be calculated as the budget for the overall project, and the duration that this particular project would normally take. In general, a project plan will be a combination of life cycle model and the parameters, the underlying parameters which I have to define. Say project life cycle model takes up a generalized framework which are a sequence of activities. This helps us to measure certain parameters like size of the project, deliverables, duration and the budget. The other definition of life cycle model would be like it specifies the various phases or the workflows of the software process, such as, I am very particular here, the previous definition was in particular, here I am very much specific mentioning the different phases. So, these phases include requirements, analysis specification, design, implementation and post delivery maintenance, and the order in which they are to be carried out. So, now that I have figured on the requirements, analysis, design, implementation and post delivery which is to be considered as maintenance, now it is up to me to decide on what is to be done in the beginning. Certain requirements would come to us which does not require any design or any analysis. So, then we can start our coding immediately. Certain other phases where this would be the first time we will be starting the work, so that requires certain amount of analysis. So, for those phases we start doing with the requirements analysis and we go for design, then we will go for implementation, but certain cases we can directly start with the implementation itself. So, what exactly is the software development in theoretical perspective? In theory, software is developed as described, it will be of a linear format, it can be started from the scratch. So, as a theoretical explanation towards software, when a project is being conceived, we consider it as an empty set and we start working on it. We collect the requirements from the end users as and when required. Once after completion of all the requirements, then we will go for the design, then we will go for implementation and finally we try to deploy that work. But this happens in theory. Why? Because people may not be clear in the beginning of what my requirements are. They cannot clearly define their requirements in full. In that specific juncture, I cannot expect the complete requirements from my end user to start with my design phase or an analysis phase. So, in that particular specification, I may have to consider the analysis and implementation with the ones that I have received. So, what my end user has posted, I will proceed with those sort of requirements. I tend to analyze on those requirements, I will implement. any advancements that I have added on top of what has been given, these add-ons will later be analyzed and be added to the original part of requirements and be added to the implementation at various levels. So this happens in theory. The same sequence, following the same sequence would majorly happen in a theoretical base. Whereas if we look at the same software development in practice, it is totally different and it is more chaotic. There are times where software professionals make mistakes. The client's requirements change while the software product is being developed. That is what I have been mentioning. The requirements of the client quite often do change. As of today, whatever requirements that they have posted, if we have started analyzing on the requirements and have started implementing, say 6 months from now on, the requirements might slightly change. Say 20% of the change would impact on my project. So I cannot finalize on the requirements and work on, because my client would come out with the requirements, change of requirements. A software product is a model of the real world, and the real world will be continually changed. So what models that we will be seeing towards this software development lifecycle would be, there are hundreds of different lifecycle models to choose from. We will be looking at certain typical models like Waterfall Model, Code and Fix Model, Spiral Model, Rapid Prototyping Model, Unified Process, Agile Methods, Extreme Programming, Commercial off-the-shelf models, but there are more variations on a smaller number of basic models. By changing the lifecycle model, what is that we can do? So we can improve and or trade off the development speed, the product quality, product visibility, administrative overhead, risk exposure, customer relations. When we shift between models, say for example, one model I have been using which goes through a sequence of phases, but this kind of a project doesn't require those sequence. It can be easily understood. Anybody who are very good at developing aspect of it, or anybody who is to be perceived as software engineer, can easily understand on these requirements, need not work on the requirements and analysis phase initially, rather they can do on the coding aspect itself. So they can directly go on the implementation aspect itself, by where the development speed would drastically increase. Product quality. The ultimate objective or the goal towards moving into this particular software engineering is to provide very good quality. Although I stress on saying, if I have followed through a sequence of such processes or a life cycle model, if I follow through this particular life cycle model, I will be providing a much of quality oriented product. Then I will be able to look at the visibility of this particular project, since I can easily track on where the error is about to happen, where are the bugs towards working on this particular project are easily traceable. There are at times administrative overheads, by where at certain level it might even cost more. So at that particular juncture, I can look at and easily track on and fix on that particular area. Involving the risk component. Certain times risk also plays a vital role towards working on the specific project. In that particular juncture, I will be able to clearly figure out where or at what juncture every level of risk could happen, and I will be looking at the customer relations also. Normally, a life cycle covers the entire lifetime of a product, from day 0 till the date of delivery, and at times it includes maintenance. The entire phase is coming under the boundary of life cycle models. So this life cycle model is the lifetime of a particular product, can be said, from the birth of a commercial data to final de-installation of date release, last release. That means I look at the design of a particular product, build it until I do the maintenance phase, say for the next 1 year after it got installed or delivered to my customer or my client. I will be looking at the maintenance for the next 1 year at the cost of the development. So till then the entire phase is being covered, which is called the lifetime of a particular product. Here we may have to note, sometimes we can even combine models. I have listed you some certain different lifecycle models, but then we can even combine certain life cycle models. Say for example, waterfall model can include evolutionary models sometimes. Like for example, onboard shuttle software. This requires not just evolutionary computing, but it also includes waterfall model on top of it. So we can also change life cycle models between releases as a product matures. Likewise, rapid prototyping model, I have developed a prototype for it, but then I'm not very much sure how this prototype would be in a large scale. So then I shift from a rapid prototype model to a waterfall model. So that can even happen. So now that we'll start looking at the different models from the beginning, the first ever model, we'll define it as a waterfall model. Talking more about the waterfall model is a classic life cycle model. It is widely known, understood and commonly used model. This generally follows a staircase approach. It can even be called as a staircase model. In some respect, waterfall is a common sense approach, and this got introduced by Royce in 1970s. Looking at this picture, this is a commonly used waterfall model where whatever requirements that I have specified would come on the top. Say for example, the user requirements. Anything that was specified by my user will be projected on the top. So with that as a key point, I'll be able to proceed with the software requirements. So I collect all the requirements from my user by where I will prepare a common user document. Then I will proceed for a software requirements, which will be a transformation from the user document to a software document. Then from after having collected all these sort of requirements, I make a simple analysis on the user and the software documents by where I'll be clear of the architectural design. So by where I'll be coming out with a framework which mentions clearly how this project or what are the phases by which this project has to flow through. Then I'll be working on the detailed design and coding phase. After that, I'll be going for the testing phase. Finally, it will be given for delivery. So this particular project is being carried out over a period of time. And not only that, after I have gone through the entire phase of user requirement, software requirement, architecture design, detailed design and coding, testing and delivery, the same can be gone upstream also, which means from the testing I'll be able to backtrack and work on the testing phase. From the delivery phase I can backtrack and work on the testing phase. Likewise, from testing to detailed design and coding phase, I can go upstream to collect or to know what my user requirements are. One nice thing that we can understand from this waterfall model is that this waterfall model has gone through a phase. Say every phase would be an execution or the completion would happen after the completion of the previous phase. That means if I assume the first two phases like user requirements and the software requirements phase, this particular user requirement and software requirement is termed in our understanding as requirements analysis phase, whereas architectural design and detailed design is termed as a design phase. Now let us take this way. This design can be done only after completion of the study. That means after I completely analyze on the project, then only I can go for the design. So we can put it in very common terms. This particular waterfall model goes through a phase where it will be called define before design, which means if I'm about to design, I should have completed my definition before. Likewise, if I'm about to code, I should have completed my design before. So this is one of the nicest thing that waterfall model has suggested. That is the reason why most of the real-time projects that we are about to develop, if at all it is not very clear, if at all it is not, we are not knowing the procedure of how to develop, we follow this waterfall model in detail. More further on the waterfall model, no phase is complete until the documentation for that particular phase. As I have already mentioned, once I am done with the user requirements phase, parallelly I will be starting developing on the documentation. So documentation at every phase of development of a waterfall model or any model would be of major impact. So no phase is complete until the documentation for that particular phase has been completed and the products of that particular phase have been approved by the software quality assurance group. So there is a specific group which assures on the quality of the software that we are trying to develop at every phase. It is not just on the overall product I assess on the quality, it is at the user level, it is at the software development level, it is at the design level, it is at the code level, it is at the test level. Every level there will be a group which will assess on the quality of the product that we are about to develop. So if the products of an earlier phase have to be changed as a consequence of the following feedback loop, as I've told you, waterfall model has an upstream. So I can take up feedbacks, I can work on the previous module and I can modify on this particular testing phase, say for example. That earlier phase is deemed to be complete only when the documentation for that place has been modified. Say if I have gone from the delivery phase to the testing phase, any updations or modifications that has happened towards the testing phase also need to be modified on the documentation part. Then only it becomes complete. Only when the documentation for the phase has been modified and the modifications have been checked by the software quality assurance group. So having studied this particular model, some of the advantages of this waterfall model are, it is an easy to understand and implement module. It is widely used and known. In theory, this particular model is the best model or very suitable model given any specific problem. And it reinforces good habits like, as I've already mentioned before, define before design and design before code. And it identifies deliverables and milestones at every terms, at every point in time. It identifies what my deliverables are and it identifies how much of time it would require to move on from one phase to the other phase. It works well on mature products and weak teams. If I understand as a manager, if I try to understand the complete requirements, but then my team is not able to completely figure out how this product is to be developed, so that means I have a weak team. In that specific juncture, I would put waterfall model into practice, by where I am making it very clear. Once after my people are very clear on the requirements, I will go for the design aspects of it. So as this particular model has many advantages, there are so many disadvantages to the system. It is an idealized approach and does not match really well. It doesn't reflect iterative nature of exploratory development, and it is unrealistic to expect accurate requirements so early in the project. So many a times I will not be able to exactly understand the requirements. As I have told before, my clients will not be very clear that they will mention all the requirements in the beginning of the work itself. So it becomes unrealistic to expect accurate requirements so early in the project. Software is delivered late in the project, delays discovery of serious errors. Whereas if I am trying to deliver a late project, there are at most delays that would be possible, which might cause serious errors when I project the software to the consumers. And it is difficult to integrate risk management. Risk management can never be taken up. I'll explain the reasons why we will not be able to process the risk. And it is difficult and expensive to make changes to the documents. Why? Because after I have gone through all the levels through the waterfall model, now that I am trying to move on the upstream to change on the documentation. It is even more happy to work from the scratch, but then it will be difficult to work or reuse on what has been done before. So to exactly look at the document and to rework on the particular document, it will be very difficult. It will have and it will be difficult and expensive to make changes to the documents. So by swimming upstream, it has significant administrative overhead and it will be costly for small teams and projects. Whereas if I work on small teams, it will be very costly when I work through the waterfall model, and it takes a lot of my time and effort. As a summary towards what we have seen for today, we have started with saying different technical activities that are required for development towards software projects, different management activities required towards software projects, and we have tried introducing a term called software development lifecycle models, whereby we have defined software development lifecycle and we have taken you to one level more, where we have understood on a specific model called waterfall model. Thank you.